What kinematics is? Kinematics is the study of moving bodies. Okay, but we don't discuss about the force in this. Okay, we talk about the speed, how fast or slow a body is moving, and how much distance is traveled in given time, and velocity, acceleration. We don't talk about force in the chapter of kinematics. Okay, actually both kinematics and dynamics are the part of Newtonian mechanics. So kinematics without force, and dynamics with the discussion of force. The forces are involved, though forces are involved in kinematics also, but we don't mention. Of course, when anything moves means some force is acting on it, but in kinematics we don't talk about the force. So the first topic of this kinematics chapter is speed, velocity, acceleration, and I have again divided this into two parts. In the first part of this chapter, we will study about distance and speed, and in the next video, you will study about velocity, displacement, velocity, and acceleration. So both distance and speed are scalar quantities, and you know well what are scalar quantities. Scalar quantities are those which do not need direction to be mentioned. So time is a scalar quantity, distance is also a scalar quantity, so is the speed. But velocity, acceleration, they all are vector quantities. Okay, so we will study about the graphical analysis of this motion of the bodies. We will, in this video, we will talk only about speed and uh, time, that is distance and time graph will be plotted, and you will work out speed from this. Okay, in the next video we will talk about displacement, velocity, time, and their graph. Okay, so first topic of this video will be the average speed. Speed tells us how fast or slow a body is moving. So usually we calculate average speed, because when we drive on the road of, or especially a busy road, the speed changes. We sometimes speed up and sometimes we slow down. So it's better to calculate the average speed. Average speed is distance over time, total distance covered by body and total time. Okay, so it's average speed, distance divided by time, and it is measured in meter per second. There are some other units, some other formula from this. They all are derived from this, like distance is equal to speed into time, and time is equal to distance divided by speed. And you must be familiar with the triangle here. What comes here in the first box? Distance. Here, speed and time. So speed is equal to distance divided by time. In the same way, distance is equal to speed multiplied time, and time is equal to distance divided by speed. So there are some conversions of speed shown here. 1 kilometer per hour. How can we convert it into meter per second? You remember kilometer per hour is also the unit of speed. Distance is in kilometer and time is in hour. So 1000 meters are equal to 1 kilometer. So you can also write 1000 meter per second. Here 1 hour, 60 into 60, that is 3600 seconds. Okay, so the time is also converted here into seconds. That is 1 hour is converted into second, and this also. So 1 kilometer per hour, distance in meter, 1000 meter divided by time in second, 3600 second. Answer comes equal to 0.28 meter per second. So you can remember this. Like 1 kilometer per hour is equal to 0.28 meter per second. Standard. Okay, so you can calculate 2 kilometer per hour. How? You will simply multiply 2 into 0.28. So your answer of kilometer per hour will be in meter per second. In the same way, if you have to convert meter per second into hours, you can see it here. How did we get this meter per second? Of course, you will make this part side subject. So when 0.28 goes to the other side, it divides. So 1 upon 0.28 will be equal to 3.6 kilometer per hour. Okay, so this is again our standard. 1 meter per second, 3.6 kilometer per hour. So 2 meter per second will be 2 into 3.6 kilometer per hour. So this is how you can convert your meter per second unit into kilometer per hour. Okay, so there is another relationship. It is in mile per hour. Okay, so this is a simple question. Average speed And these type of question you did in your class 8. So you have to simply calculate the average speed, total distance is given, and total time is given. Answer 25 meter per second. Here there is a table, and you have to complete the table. Here I am just telling the answers quickly in this video, and you will do the calculation yourself and see whether the answers which are appearing here in the video are correct or not. So distance 60, time 3 seconds. So 60 divided by 3 is 20. In the same way, 40 and 35, these two values are given. Calculate distance. So of course you will multiply. Distance is equal to speed into time. What comes? 1400 meters. Okay, so this is 0.2. So this is how we complete the table. This is kilometer per hour, and this is a bit difficult. The time is given in minutes and seconds. 8 minutes and 20 seconds. So 8 minutes can be converted into seconds if you divide, multiply this by 60 and add it to remaining 20 seconds. So answer will come in seconds. So and kilometer you can convert it into meter. So answer will be this. Yeah. And this is last one. Okay, now we talk about the graph, because this is a very important part of your syllabus. You have to analyze the graph, you can calculate the gradient of the graph, you can calculate the area under the graph. Okay, so here this is a simple graph. The table is given here. Distance is in meters, and 1000, 2000, 3000, 4000, 5000, 6000. So the body has started from rest. Distance at time t equals to 0, distance is 0 means body has started from rest. Okay, after 40 minutes, 40 seconds, body has covered 1000 meters. 80, 2000. Okay, so this is to be plotted taking time along x-axis and distance along y-axis. So we get a straight line. So these values are simple to understand. So the graph is a straight line means the body is going with a steady or constant speed. Okay, straight line shows this. Slope or gradient of a distance time graph increases with the speed. The faster the speed, the greater will be the gradient of the graph. Gradient always of distance time graph gives you speed here. So here distance along y-axis, time along x-axis. Two graphs are shown here. The red one, this is less steeper compared to blue one. It means this body, which is whose speed is shown in red color, is slow compared to the body which is shown in blue color. Okay, it's a greater value of slope, greater change in distance with time, so it has faster speed. Okay, so here this is given in the graph opposite. You have to calculate the gradient. So when the graph passes through origin, two values for the gradient can be taken as what you know the formula y2 minus y1 over x2 minus x1. Changes in the values of y-axis divided by changes in the values of x-axis. So the y2 is taken as 150 and x2 is 10. Okay, and y1 is 0 because at t equals to 0, distance is 0. Body has started from rest. So both x1, y1 are 0. So y2 minus y1. 150 minus 0 divided by x2 minus x1, 10 minus 0. Okay, so speed comes 15 meter per second. Now there is again a question. You have to sketch the graph on the same axis for a car moving at a steady speed. This. Okay. Bus moving at a steady speed greater than the car. So you must be knowing it now that this will be a straight line graph passing through the origin here, and it is having greater slope compared to the slope of the car's motion. This. Okay. Now the third part, lorry increasing speed. Up till now we discussed only about the uniform speed. Here the speed is increasing, means gradient will not be same. Gradient will also be increasing like this. So here the lorry has started from rest and it's moving at lower speed in the beginning, because if you calculate the gradient of the graph here in the beginning, it will be less, and gradient is, it is becoming steeper and steeper. Okay, and after this it acquires greater constant speed. Okay, because the graph is a straight line again, so this is a constant gradient. So gradient, if you divide this whole graph of this lorry into three parts, you will see, like in the beginning here, then in this part and this part, you will get three values of gradient. So gradient of the moving lorry is not the same. Okay, so it means it is not constant gradient, so it is having increasing speed. Now you have to describe the motion of the lorry here. Another question, and x, y, and z. Okay, in this graph. So x, you can see here, it is the fastest one because its gradient is greatest. Y, it is also moving at a steady speed, but gradient is less than that of x. Motion of x is a little bit different. It is moving with the constant speed up to 600 seconds of time, and then it stays. It does not move. This portion of the graph which is parallel to x-axis means no change in the distance with the time. Time is changing, but distance still 10,000 meters. It means body is stopped. Okay, for how long? 1200 minus 600 means for further 600 seconds body does not move. Okay, then it starts moving again, and it acquires a steady speed, and in the time of total time of 1800 seconds, it covers a distance of total distance is 20,000, but the distance in this interval means 1800 minus 1200, that is 600. In this interval of 600, it covers a distance of 10,000 meters. Okay, now we will just analyze the motion quickest, and we can calculate the speed by taking total distance divided by total time. Okay, total time is 1800 seconds for all the vehicles. So maximum distance is 45,000 meters. So speed is 25 meter per second. For lorry Y, the graph was shown here up to this distance. Time in time, 1800 second. Of course, it is slow compared to y to x, so it has covered less distance compared to this uh, lorry x. Okay, lorry y has covered in 1800 seconds the distance of 36,000 meters, so its speed is less. Lorry z, so lorry z it stayed and during the journey, like after 600 seconds it not move. So how will we calculate the average speed of this? Total distance it covered divided by total time. So the total distance in the beginning of first 600 seconds, this is the speed, and it was stationary. Then 1200 seconds to this 1600 meter per second. So average speed, total distance it covered was 20,000 meters in 1800 seconds. So it is the slowest one. Here this is to be filled in. You have to choose the words. What comes in these blanks? Let's see what comes here. Distance. Speed is equal to distance divided by time and can be measured in meter per second. Okay. And here a speed of 20 meter per second is the same as dash. You solve it first and fill in this. Okay. Of course, the number comes either 40 or 72 will come in this blank. 72. Okay, this part is not necessary to do this part. Miles per hour, usually not asked in your Cambridge examination. Now slope of this graph, speed, higher speed, greater gradient, higher speed. Now this is over, and let's get ready for the next topic in the next video.